Hello friends, so let us start with the second session. In first session we discussed about the definition of inverse function, right? Also we discussed some points related with the functions, in which we discussed one, onto and many to one functions, and then we discussed about the domain and range of our six trigonometric function, also with the inverse also, or inverse functions also, right? So today we'll start with the graphs of all those functions. Graphs of functions, basically the inverse function, right? Graphs of inverse functions, right? So first of all, let's talk about sine inverse x, and we know that this sine inverse is defined from -1 to 1 to minus pi by 2 to pi by 2. This is the domain and this will be the range, right? So if I want to plot the graph of this, so the domain will be from -1 to 1 and range will be from minus pi by 2 to pi by 2. So when you put x equals 1, the answer will be pi by 2, and x equals -1, answer will be minus pi by 2, and x equals 0, it has answer 0, right? So the graph will be something like this. This will be the graph of sine inverse x. Okay, this is the graph of sine inverse x, right? We already discussed in the last session that for all the functions we have some restricted intervals, right? That's why I can get the graph of sine inverse x only in between minus pi by 2 to pi by 2, right? But it is not necessary to get this interval only. We can get the graph of inverse in between pi by 2 to 3 pi by 2 also, then minus 3 pi by 2 to minus pi by 2 also. But as far as the syllabus and textbook is concerned, we have to obtain the graph in between minus pi by 2 to pi by 2 only. So how many things we can obtain? So first thing, we can say that this function is always increasing. It's always increasing. And the second, it's an odd function. Right? So now, maybe if you have any doubt that what is odd function. So let me clear that point. Right? So if for function f of minus x equals fx, then we consider this as even function. And f of minus x equals minus fx, then we consider that as odd function, right? That is the definition. But what is the meaning of that? So if any function is symmetric about y-axis, symmetric about y-axis, right? So this function can be considered as an even function. Let me say the example of a function y equals x square. If you just check, this is the graph of y equals x square. So we can say that if you consider y-axis as a mirror, so whatever graph we can obtain on the right side, the same graph we have on the left side, right? So we consider this function as an even function, because if you go any point on right side and if you take any point on left side, so at both those points your answer of the function remains same, right? That means if you put 2 or if you put minus 2, both will give you answer as 4, right? And for odd function, it is symmetric about y equals x line, or in other words we can say it is symmetric about origin. Or in third way, we can say that the graph of the odd function is symmetric in the opposite quadrants. Let's say graph of x cube. So if you check, the graph of x cube will be something like this. This can be the graph of x cube, right? So just check, whatever graph you have in the first quadrant, the similar kind of graph we have in the third quadrant, right? So in other words, we can say that it's symmetric about a line y equals x. This dotted line is y equals x, so it's symmetric about the line y equals x. Just like we have the graph symmetric about y-axis for even function. So if we take some point on the right side, let's say 3, and if we take the same point on the left side, then both this answer has same value but with the opposite sign, right? So that's why we consider this as an odd function. So if you now just follow these two rules, and if you just check the graph of sine inverse x, we can say that sine inverse x is an odd function, right? In the further theories, we're going to use this point. That's why I'm telling you right now. Now second, let's talk about cos inverse x. we know that cos inverse x has also range domain minus 1 to 1 and range 0 to pi. Okay, so now if I want to plot the graph, so it will be minus 1 to 1, right, 0, pi. At x equals 1, function has answer 0, and at x equals minus 1, function has answer pi. Okay, so this will be the point 1 0, and here there is a point minus 1 and pi. At pi by 2, at 0, when I put x equals 0, answer of cos inverse 0 is pi by 2. So the graph of cos inverse is something like this. Okay, so now what you want to consider that it's always decreasing. It's always decreasing, and you find that it's neither even or nor odd. Neither even nor odd. So we consider this function as a null function, meaning neither odd nor even. Okay, so this can be the graph of cos inverse x. The second thing you need to observe that the graph of this cos inverse is always above x axis. That's why the range is 0 to pi, which is always positive. Okay, then let's talk about the graph of tan inverse and cot inverse. Number 3, let's talk about graph of y equals tan inverse x. We know that it has range R and it has domain R and range minus pi by 2 to pi by 2. So as the range of tan inverse x is minus infinite to infinite, right, at minus pi by 2, and here is pi by 2. The reason I am plotting the dotted line because it has an open interval, right? So at minus infinite, tan inverse has answer minus pi by 2, and at infinite, tan inverse has answer plus pi by 2, and at 0 it has 0. So graph of tan inverse is something like this. Okay, so how many things we can conclude? It's always increasing, and second, you can consider that this is an odd function. Okay, similarly, number 4, if we talk about, let's say, cot inverse x, where r to 0 to pi. Okay, so if I talk about cot inverse, so again from minus infinite to infinite, right, this is the line pi. At minus infinite, cot has answer pi. At pi by 2 it has answer 0, and at infinite right, at infinite it has answer 0. So the graph will be something like this. So what we observe that it is always decreasing, and second, again it's a null function. Null stands for neither odd nor even, because the whole graph is above x axis, not symmetric to y axis and not symmetric to y equals x line. Okay. Then let's talk about number 5, y equals sec inverse x. We know that it's from r minus 1 to 1 to 0 to pi minus pi by 2. Okay, so if I say that here it is 1, here it is minus 1, this is the dotted line for pi by 2, because pi by 2 will not be in the range of sec inverse. Okay. So if I start from 1 to infinite, the graph of sec inverse is something like this, and if you just plot the graph from minus 1 to, so it will be something like this, because here the point is pi, so here something like this. Okay, so this is how the graph of sec inverse x, like this. Okay, at minus 1, sorry, I just wanted to stop at minus 1. Okay, so at minus 1, if this is pi, so So here I have to end. So if you just check that this interval -1 to 1, there is no graph. That means in between -1 to 1, we don't have any value for sec inverse. But as if you just check, if I just wanted to plot the sec inverse and cos inverse in the same, I can say dimensions, in the same coordinate geometry, so this can be the graph of cos inverse, right? So consider this is a graph of cos inverse x, and these two parts are related with the sec inverse x, right? That is just for your concern. Okay, so what you observe, that it's constantly increasing, always increasing, and second, it is again non-function, which is neither odd nor even. Okay, and then number 6, y equals cosec inverse x, again from -1 to 1, and minus pi by 2 to pi by 2 minus 0. So for this graph, I need to take dotted line for 0, because 0 is not in the range. Here the point is minus pi by 2, here the point is pi by 2, here it is 1, and here it is minus 1. Okay, so at 1, cosec inverse x has answer pi by 2, so it will be considered something like this, and at minus 1 it has answer minus pi by 2, so it will be something like this, right? And in between them, the graph of sine inverse is something like this. This is the graph of sine inverse x. Okay, so what you understand from this, that it is always decreasing and it is an odd function. It's an odd function. Okay, so hope you understand the graphs of the inverse functions, right? So now from using these conditions, let's talk about next theory, which is related with the opposite values theory. Okay, I consider them as a note number 3. First two notes are related with the domains and ranges of function and inverse, right? Now let's talk about note number 3, which is mainly related with the negative sign, right? So you can easily understand now what could be the answer of this, because it's a basic rule that if function has replaced by minus x, so it can be either written as minus fx or it can be written as plus fx. This when it is an odd function, and here when it is an even function. So we already discussed from the graph that sine inverse, tan inverse and cosec inverse are odd functions, right? So their answer can be directly considered as minus sine inverse x, minus tan inverse x, and minus cosec inverse x. Clear this point? So what about cos inverse, quad inverse and sec inverse? So for cos inverse minus x, we have to write down pi minus cos inverse x, it's pi minus quad inverse x, and it's pi minus sec inverse x. Okay, now how it is possible? So I am just plotting a graph of cos inverse for understanding this, right? I am just telling you this point, and by using this you can able to understand quad inverse and sec inverse also. Okay, now if you observe that if we talk about sine inverse or tan inverse or cosec inverse, if you just observe the graph of all these three, so the graphs of these three functions are something like this. This is the graph of sine inverse, this is the graph of tan inverse, and this is the graph of cosec inverse. What do you observe? When I am using positive values of x, I get answer in positive number, right? When I use negative sign of x, that means the negative value of x, I will get all the answers in the negative y direction. You just observe the graph of tan inverse also, and just observe the graph of cosec inverse also. You find this condition in all three graphs, that for positive x values, the graphs are in positive region of y, whereas in negative values, the graphs are in negative region of y. That means if you put 1 by 2 and if you put minus 1 by 2, so at 1 by 2 if it has answer pi by 6, then at minus 1 by 2 it has answer minus pi by 6. So it directly consider as a negative minus sign outside, negative sign outside. Whereas if we talk about the remaining three functions graph, that is cos, right? Then cot, and then sec. Like this. So what you observe? That for the positive values, here there is point pi by 2, here there is point pi by 2, and here the dotted line of pi by 2. So if you just observe, all these three graphs has positive answer for positive values of x. Just check the graph. In between 0 to 1, when I put all the positive values, the graph is in the first quadrant only, right? The answer of the graph is in between 0 to pi by 2 only. But whenever I put the negative values, the graph will be in the region pi by 2 to pi, right? So therefore, to convert negative values into 0 to pi, we have to subtract the positive value from the pi. Hope you understand this point. In sine inverse, in tan inverse, and in cosec inverse, positive value of x contains positive value of y, negative value of x contains negative value of y. But whenever we talk about cos inverse, cot inverse, and sec inverse, as far as positive values are concerned, we'll have answer in positive region. But for negative values of x, we contain region in the second quadrant, that is pi by 2 to pi. Right? So to convert the negative values into pi by 2 to pi, we have to convert pi minus, and pi minus. Clear? Let me take one example. If I go with cos inverse of minus 1 by 2, and if I go with the sine inverse of minus 1 by 2. Okay, just let's forget about all these graphs. Let's just talk about sine inverse and cos inverse. Okay, so as we know that this is the graph of sine inverse, and this is the graph of cos inverse. When I put negative value of x as minus 1 by 2, I will clear with the answer of sine inverse in the negative region, that is with minus pi by 6. But when I put negative value in the cos inverse, it is not negative, it's above pi by 2, between pi by 2 to pi. So what I will write down? I will write down pi minus cos inverse half. And the same thing, what now if cos inverse half is there? So half will be something over somewhere over here. So it will be considered as pi minus, now cos inverse half as pi by 3. So now the answer of this is 2 pi by 3. And where 2 pi by 3 placed? 2 pi by 3 will be somewhere over here, which is between pi by 2 to pi. So hope you understand this point. That why we are putting pi minus, and pi minus when it's about cos inverse, cot inverse, and sec inverse. Because the negative sign of cos, cot, and sec gives the answer in between pi by 2 to pi. Okay, so this is the reason behind that. Okay, then, so this is one of the important points for you, right? This is note number 3 for the negative sign. Now let's talk about note number 4, which is very important, where sine inverse x plus cos inverse x equals pi by 2, tan inverse x plus cot inverse x equals pi by 2, and sec inverse x plus cosec inverse x is equals to also pi by 2. Now, if you have any query that why it is only with sine inverse cos inverse combination, why it is only combination of tan cot, the very first thing is both sine and cos has domain minus 1 to 1, both tan and cot has domain belongs to R, and both sec and cosec has domain R minus 1 to 1. This is the very first rule. Right, and it's a basic rule of a function that if you want to do addition or subtraction or multiplication or division of any two functions, you must have to take the intersection of their domain first. And as we already studied, sine cos has same domain, tan cot has same domain, and sec cosec has same domain. Okay, now let us give the solution of one of the rule, right? I'll give you the example of this. Okay, just check. I take that let sine inverse x as theta. So what will be x? X as a sine theta. Now can I replace sine theta as cos pi by 2 minus theta? X equals cos pi by 2 minus theta, right? And then I can consider cos inverse x as what? Pi by 2 minus theta. So now theta plus cos inverse x as pi by 2, and what value of theta we assume? Sin inverse x. So this is how we can get sin inverse x plus cos inverse x as pi by 2. Okay, so also you consider understand by using this proof also, right? So similar proof you can give for number 2 and number 3 also. Okay, so if you find a question, like this, that if what sin inverse minus 1 by 2 plus cos inverse minus 1 by 2 has answer, so it's directly equals to pi by 2. No need to go with any kind of explanation. Okay, so here we're going to end our second session, right? So in next session we'll continue with the theories.